So to evaluate this integral, we can use the fact that the integral operator is a linear operator, which just means it works kind of like the distributive property. You can break it up into two separate integrals like this. And then the antiderivative of 3. That means we're trying to think of something so that when we evaluate the derivative, it gives us 3. So that's 3x, right? Because the derivative of 3x is 3. So there's our antiderivative. Now we just need to evaluate the limits of integration. So we're going to eventually plug in 4, see what happens, and subtract what happens when we plug in 1/3. Then same thing over here. Now we need to think of some function whose derivative is just 1 over x. And that function is natural log of x, because the derivative of natural log of x is 1 over x. Then evaluate the limits of integration. So over here, what this notation is saying is to plug in 4 for x, then subtract what happens when you plug in 1/3 in for x. Then over here, this notation says plug in 4 and put the whole thing in parentheses because you got to subtract whatever this result is. So this entire evaluation needs to be in parentheses. So natural log 4 minus natural log 1/3. So 3 times 4 is 12. 12 minus 1 is 11. And then calculator for this. You could leave it as this natural log notation. This is subtracted by natural log 4, and then plus natural log. Now that's 1/3, or in other words, 3 to the negative first, right? And so there's a rule about logarithms. If you can write the argument of the logarithm, meaning the thing inside the parentheses, if you can write that in terms of an exponent, then the exponent can come out front and multiply. So now that's a minus natural log 3. Okay. And then there's still a little more we could do to combine this logarithm. I'm not sure how far I should go into this. I guess it looks like the book's answer does go pretty far into it. So we can, there's another rule about logarithms. If you have like natural log of x, notice that's a positive natural log of x, minus natural log y, that's natural log x divided by y. So we just need this to be a positive out front. So this is 11 plus natural log 4 to the negative first. And then we can use the logarithm rules. If you have a logarithm subtracted by another logarithm of the same base, then you can make it a logarithm of the first argument divided by the second argument. And then we can simplify it a little more, because 4 to the negative first, that's 1/4. So then 1/4 can come down and multiply. But this is 12 to the negative first, so that's the same thing as natural log subtracted by natural log 12. So there we go. That's, whoops, sorry. That's what a book would have for an answer. For the calculus class I'm currently teaching, it sounds like logarithms were a hard time in the previous semester. So on the multiple choice answers, what you're going to see is you could just do this with your calculator and make a decimal approximation. Okay, so on the test there will be multiple choice and there will be decimal approximations.